Hello students, welcome to today's session of chemistry. As you all know, we have started fifth lesson of your syllabus, that is electrochemistry, in the previous session, and this lesson has a weightage of 5 of 7 marks. We will just revise the points or the basic concepts we learned in the previous session. First and most important thing is definition of electrochemistry that we learned is the study of interconversion of two types of energies, that is electrical energy and chemical energy. So these two types are interconvertible. Chemical energy can be converted into electrical energy in the same way electrical energy can be converted into chemical energy, and both these interconversions are important and those are studied in this branch of chemistry which is known as electrochemistry. This is the basic thing. Now for that we learned about electrochemical cell. It is the device in which these interconversions take place. Okay. Now, what is electrical conduction then? Electric conduction means electric current or charge transfer or flow of electricity. So, electric conduction represents a charge transfer, and that charge transfer or flow of electricity occurs through substances called conductors. So we learned about conductors also. Conductors are of two types: metallic conduction, where electric conduction or charge transfer takes place through metals, which involves direct flow of electrons from one point to other. In the same way, second type is electrolytic or ionic conduction, where electric current is transferred by the movement of ions of the electrolytes. Then what are electrolytes? The substance which undergoes dissociation to produce ions in aqueous condition or in molten condition is called electrolyte. There are only three basic electrolytes we must know. The first one is acid, which may be strong or weak, base, which may be also strong or weak, and third type is salt, formed from these acid and base by the neutralization reaction. Electrolytes are also of two types: strong electrolytes and weak electrolytes. Strong electrolytes, those exhibit high conductivities, and the weak electrolytes, those show lower conductivities, because weak electrolytes are the weak acids or weak bases that dissociate to a very small extent, while strong electrolytes are strong acids and strong bases along with salts. They get dissociated almost completely, and hence they produce large number of ions, and hence charge transfers occur at a very high rate, and hence they are called strong electrolytes. Understood? These are the basic concepts we learned in the previous session. Now let us start with this section. Now we know basically what is electric conduction. It is charge transfer, or we say flow of electricity. Now how to measure, or what is the formula to measure electrical conduction? So we will learn about electrical conductance of solution. For that, one law is there. So according to Ohm's law, the electrical resistance R of a conductor is equal to the electrical potential difference V divided by the electric current I. So according to Ohm's law, R is equal to V upon I. Directly we can say V is potential difference and I is current. So what will be the unit of R then? As you know, SI unit of potential is volt, and that current is ampere, which is denoted by A, and potential is denoted by volt. And hence, the unit of electrical resistance will be V per ampere per A, or V raised into A raised to minus 1, and which is called ohm. Ohm means V into A raised to minus 1, or it is denoted by the symbol omega. So R is equal to V upon I, and its unit omega will be equal to V into A raised to minus 1, or we can say A V per ampere, volt per ampere. Understood? So this is about a resistance. We want to know about conductance. Then what is conductance means? The electrical conductance G of a solution is a reciprocal of resistance. That means G is equal to 1 upon R. Resistance we learned upon according to Ohm's law. Now we will learn about conductance, which is opposite to that of resistance. Hence G will be equal to 1 upon R. Then what will be the unit of G then? SI unit of G is Siemens. Like R, we said unit of R is omega. Like that, SI unit of G or conductance is Siemens, which is denoted by S, capital S, which is equal to per omega. Naturally, because it is reverse of resistance, hence reverse of omega. So unit is omega raised to minus 1, or per omega. Therefore, we write Siemens S equal to per omega. That means exactly that of opposite to resistance will be A into V raised to minus 1, equal to C into V raised to minus 1 into small s raised to minus 1. Now what is C and small s here? C represents Coulomb, which is the unit of electricity related to current strength in ampere and time in seconds. S, small s represents seconds, time in seconds. So Coulomb is the unit of electricity. What we say? C equal to A into S. Current flowed for this much time is Coulomb. So unit of electricity Coulomb is related to current strength in ampere and time in second. Thus, this is the formula for S. Siemens equal to per omega. That means A into V raised to minus 1 equal to Coulomb per second per volt, we can say. Understood? So this is about conductance G. So C will be equal to, according to our formula, C will be equal to A into S. Now, the electrical resistance of a conductor is proportional to length L and inversely proportional to cross-sectional area A. Thus, R is directly proportional to L upon A. What is C? Coulomb equal to A into S. We learned that. Now, one more sentence. The electrical, or one more concept we say, the electrical resistance R of a conductor is directly proportional to length L and inversely proportional to cross-sectional area A. This is for metallic conduction. We learned it in physics also. So what will be? R is directly proportional to L upon A, or we will take one proportionality constant, and then R will be equal to rho into L upon A. Rho, it is the proportionality constant and is called a resistivity. This rho is called resistivity. What is it? It is proportionality constant. Then, if you want to define rho, how can we define rho? Rho can be equal to, resistivity can be equal to resistance when L is equal to 1 and A is equal to 1. Or we can say unit length and unit cross sectional area. If we take these two factors 1, then rho will be equal to R, or we can define resistivity as it is the resistance of a conductor of unit length and unit cross sectional area. So R will be equal to rho into L upon A. This is the formula we got. Understood? So remember that formula. R equal to rho into L upon A. What is R? R is resistance and G is equal to 1 upon R. So let us start with conductivity. Now we learn about resistivity. Rho. Resistance R. Now actual conductivity. It is not conductance. It is conductivity and is denoted by symbol K. Now we have seen that G or conductance is exactly opposite or reverse of that of resistance. That means G equal to 1 upon R. Now according to our law, what we just now said that resistance of a conductor is proportional to L and inversely proportional to A. So reverse of that will be, then the law will be like this. As R is directly proportional to L and inversely proportional to cross-sectional area, then G is directly proportional to A and inversely proportional to L, opposite to R. Hence, we can write G is directly proportional to A and inversely proportional to L. Again, we will take one proportionality constant. G equal to K into L, A upon L. This is K. What is conductivity we said. Rho is resistivity. Proportionality constant for resistance equation. In the same way, for conductance equation, we get one proportionality constant and that is K, which is called conductivity. Thus, G equal to K into A upon L. The proportionality constant K is called conductivity. G can be equal to K. G can be equal to K when A should be 1, again L should be 1. So, the length and cross-sectional area of conductor are unity, then G will be equal to K. So, again we can define conductivity in that sense. Thus, conductivity is the electrical conductance of a conductor of unit length and unit area of cross-section. A should be 1, L should be 1, then G will be equal to K. So, conductivity is the electrical conductance of a conductor of unit length and unit area of cross section. So this is K. Now we will equate all these equations. Then what will be K? K equal to G we said. That means G, in other words, conductivity is the electrical conductance of unit cube of material. Understood? Unit cube of material. Both should be unit or 1. From equation, above all equations, if we equate the conductivity of a solution of an electrolyte is called electrolytic conductivity, which refers to the electrical conductance of unit volume of solution. Now, in case of ionic or electrolytic conductor, what will be the formula then? We learn about metallic conductor. Now, electrolytic conductor, if we want to say, then conductivity of a solution of an electrolyte is electrolytic conductivity of unit volume of solution. The solution, it should be measured in cubic meter or cubic centimeter. If that volume is 1 cubic meter or 1 cubic centimeter, then conductivity of a solution of an electrolyte is called electrolytic conductivity in case of electrolyte conductors. Understood? So, if we equate, so formula for this all these things. So if we equate above equations, then we can write K will be equal to G into L upon A, because we have seen that G equal to K into A upon L. So reverse that equation, then we want to find out the formula for conductivity K. So K will be equal to G into L upon A. But what is G? G is 1 upon R. Hence, it will be equal to 1 upon R into L upon A. So, we got the formula for K is equal to 1 upon R into 1 L upon A. So, all these equations, if we combine, then we can easily say that K will be opposite to that of resistivity. Then K will be equal to 1 upon rho. Rho is resistivity. So, conductivity and resistivity are exactly opposite. So K will be equal to 1 upon rho. Now, like conductance and resistance, we said that G is equal to 1 upon R, or resistance is opposite to that of conductance. In the same way, conductivity is opposite to that of resistivity. Understood? This derivation, just write down the equations one by one repeatedly, then you will understand this derivation. So better way, open your textbooks, go through it, you will find the same formula there, and read it again and again to understand the meaning. Now units for electrolytic conductivity we'll see. So electrolytic conductivity, SI unit also we see, and common unit. For length, SI unit is meter, but the common unit is centimeter. Area in the same way, square meter. Common unit will be square centimeter. Resistance, SI and common unit is same, that is omega. And conductivity is opposite to that of resistance. So 1 upon rho we say, that is per omega per meter. Or per omega is Siemens. So Siemens per meter or per omega per centimeter we can say. So these are the units for electrolytic conductivity. This formula is very important. K equal to 1 upon rho. So assignment for this time is same. Prove relationship between conductivity and resistivity. K equal to 1 upon rho. Understood? So write down this. You please open the textbooks. It is there. So write down all the details, equation numbers, and you will find the formula. Now, this is one more request to all of you. Just be there with me in this lesson. Every time when a video about electricity, electrochemistry comes, just observe it repeatedly. Open the textbook, simultaneously read the textbooks, try to understand the basic concepts. It will make you easier to understand the lesson. And understanding is very important as far as electrochemistry is concerned, because it is not only theoretical lesson, some numericals are also there. That means some formulas and some derivations are there. If you understand the lesson, then only you are able to write the derivations. So try to practice those derivations. Thank you.